Hi everyone. Today we're going to be talking about Boyle's law, which is the first of the gas laws that we will be reviewing. So in this lesson, we are going to be talking about pressure, the different units of pressure that we can use. We're going to be stating what is Boyle's law, so what variables are involved, and which ones are held constant, and then apply Boyle's law to some actual calculations, which is pretty easy to do. So the first thing we have to keep in mind is when we're talking about Boyle's law, when we're talking about a gas, we also have to talk about pressure. So pressure is measured by looking at how much force is in a given space or a given area. So it's the measurement of how much force is pressing in on something. So higher pressure, higher force pressing in on that area. For pressure conversions, we've seen these before in our last unit, but all of these are equivalent to one another. So what that means is if I want to measure 1 atmosphere in kilopascals, that's going to be the same as 101.325 kilopascals. So these are all basically unit conversions that you can switch one to the other. So some other things when we're looking at gas laws, so obviously gases, we can measure their pressure. We can also measure their temperature, which if you remember from the last unit, is a measurement of kinetic energy, okay? We can also measure their volume, so how much is in there, and we can measure the amount that is in it, or moles of gas, so how many particles are there. In Boyle's law, we are looking at this specific equation. So we're looking at pressure and we're looking at volume. So those are the only two variables we care about. With Boyle's law, your pressure can be, and your volume can be in whatever units you want, but the key here is that they must be the same units on both sides of the equation. So that means if I have atmospheres on the left side, I've got to be using atmospheres on the right side. We would consider then that these are the two variables that would remain constant, your temperature and your moles of gas. Those things are not changing. So one thing that we do see is that pressure and volume are inversely proportional. What that means is as pressure goes up, volume goes down. As pressure goes down, volume goes up. So these are inverse. You must remember that they are inverse from one another. So let's try some practice problems. Our equation for Boyle's law is P1V1 equals P2V2. And if I read through this problem, I'm given a couple different things to work with. One of the things that I'm given is this sample of oxygen gas is occupying 250 milliliters at 740 torr. So if I want to go through and label this, this is my initial volume, the 250 mLs, and that 740 torr is my initial pressure. Why did I write P2 there? Oops. Pretend it didn't say that. Why won't it erase now? Oh my God. There we go. Okay, that should be P1. Okay, so you have V1, P1, and then it's asking you what volume, so our unknown is volume 2, will it occupy at 8.50 torr, or sorry, 8.0 times 10 to the second torr. I don't know what's going on with me. That's going to be our second pressure, okay? So if I look at my equation, I know P1, I know V1, and I know P2, but I don't know V2. That's what I'm going to be solving for. So all I have to do is plug in my numbers. And if I check here, both of my pressure measurements are in torr, so I don't need to worry about converting everything. It's pretty much good to go. So I'm going to plug in these numbers. Your first pressure is 740 torr. Your first volume is 250 mLs. Your second pressure is 8.0 times 10 to the second torr, and volume 2 is our unknown. So you're just going to do the algebra and solve for V, which we find to be equal to 231.25 mLs. So that's what our V2 is equal to. Incorrect significant figures, this would be 230 mLs. So let's try another one. Here we have a sample of CO2. It has a volume of 3.50 liters at 125 kilopascals. What will the pressure, or what pressure will it exert if we decrease the volume to 2 liters? So you're given 2 volumes and 1 pressure. This is your first volume. This is your first pressure. This is your second volume. and we're trying to figure out what pressure it's going to change to. That's going to be P2. That's our unknown, okay? So our equation is still that P1 V1 equals P2 V2, and we're just going to plug in our numbers from here. I also see that it's liters on both sides, so I don't need to worry about getting my volumes to the same thing. They're good to go. So 125 kilopascals times 3.50 equals P2, which is our unknown variable, times 2.00 liters. And again, you're just going to solve algebraically and figure out what that P2 is equal to, which in this case is 218.75 kilopascals. In correct significant figures, that's going to be 219 kilopascals. And let's check if this math, checks out. Remember that as pressure goes up, volume goes down, and as pressure goes down, volume goes up. So if we look here, we decreased our volume, okay? We dropped the volume down to 2 liters. If you see here, it's 2 liters. That's our volume 2. So I should expect the pressure to be higher than 125 kilopascals, what I started as. And is that the case? Yes, that's what happened. So let's try one more practice one together. So here we have chlorine gas. It's occupying a volume of 1.0 liter at 7.20 times 10 to the second torr. What volume? So that's V2. We have V1. We have P1. We're trying to find the second volume if we change the pressure to 1.20 atmospheres, okay? So we still have the same equation we're working with, but something's different about this equation. If you look here, our units for pressure 1 are torr, and our units for pressure 2 are atmospheres, and they have to be the same. So what I'm going to do is convert 7.20 times 10 to the second torr into atmospheres. I'm going to convert that torr to ATM using those conversion factors that we have on that first, those first couple slides. So if I look back, I know that 1 atmosphere is 760 torr. So this initial pressure, P1, is actually 0.947 atmospheres, and that's the number I want to go with. So now I have 3 of my 4 variables. So I have 0.947 atmospheres. My volume is 1.00 liters. My new pressure is 1.20 atmospheres, and I don't know what my new volume is. That's my unknown. I can find that V2 is equal to 0.789 liters, and that number of sig figs is good. So hopefully by now you understand those basic conversions and you're able to do some simple Boyle's law calculations.